this is what we're going to do now. Hands-on exercise. We are going to develop this curve. We're going to replicate this curve, and this curve that Mepdg does using our Excel sheet. Now we're going to all develop an Excel sheet. Okay? So I already sent you this Excel sheet that is not ready to go. So you will be typing actual equations in it, and then we will do this together. And that's the best way of learning. Now, the first step, what we will do is, this is the input data, and these steps are kind of explained here a little bit. This is the input data that you would be inputting to the PVNME. So these are the temperatures and G stars and phase angles, that's an input, you input. And these are the dynamic modules at different frequencies and the time, temperatures. These are also input. This is actually real data for an PG70-28P 4E30 mix that is taken from metro area. So what we'll do first is, from this data that we have, we are going to calculate temperature versus viscosity by just multiplying the G star by 1 over sine delta to the power this, divided by 10. So we will calculate the viscosities. Then we're going to take the log of the viscosity, and then we're going to take log of the viscosity. Then that will be the number that you're going to get. And then this is the numbers, log of the temperatures that we're going to get. Let's do that first. Let's do the step 1. Okay, how many of you Excel sheet is up and running on your computers? You're ready? Okay, you can work with Adnan together. All right, let me ask. Everybody online, Alex, Bill, Joe, do you have all this Excel sheet ready to go?
The Excel sheet is ready to go.
I'm ready to go.
Excellent.
Yes, it's ready.
Excellent. Okay, so this is the Excel sheet. You can see Excel sheet only includes the temperature versus G star delta input is here. So the rest, we are going to fill them out. First, we need to calculate the temperatures in Rankine. That's what the equation is based on. So we have to convert the temperatures here into Rankine. So if you look at the temperatures in Rankine is simply temperature in Fahrenheit plus 459.67. Let's do that. Equals this temperature plus 459.67. Okay, so I got it here, 499.67. Let's move this calculated all for all. We have all the temperatures. Okay? You can stop me anytime. I'm not going to ask for individually, just you stop me if we're going too fast, when I go too fast. Second, calculate the viscosity in centipoise. So here's the equation. Let me just copy this and paste it. You can do the same if you want. Let me paste the equation here. You have a hard copy. How can I copy it? I'm just joking. Okay, so you can see it here from also. You can't copy paste from a hard copy. You can take a picture, right? Okay, so here's equals. All right, G star is in pascals. First, I'm going to multiply everything by 1,000, just to unit conversion. So you don't ask me why. Unit conversion, multiple 1,000 by. So then we will do this because units are different. I want in centipoise. G star is here, divided by 10, multiplied by parenthesis 1 over sine of delta. Well, in this case, delta is in degrees, so we have to convert to 2 radians for the sine to work. So delta divided by pi times 180. pi times 180. So I got the sign, close the parentheses twice, to the power 4.8628. That's great.
Parentheses after pi. After pi.
After I have it.
You have an open close together.
Let's do it again. Okay, I will do this again. So 1 over sine this divided by pi, right, times 180, right? Huh.
Getting the same error.
You're getting the same error.
I don't.
Let's just convert. Let's make these things easier. Let's convert. Let's create a little column here. Convert this to radians. Equals delta divided by pi times 180. Why am I doing? Okay. I'm doing it opposite, that's why. Divide by 180. Divide by 180 times pi, right?
There's also a command to convert directly into radians.
Equals radians.
Exactly, yes. Like radians. So that I can give the appropriate credit. Who said that?
Bill.
Bill?
It was me.
Okay. Radians. This. Voila. So let's delete this column back. Okay, how many of you did this? Only 2? How many of you did not do this? Okay, let's wait for a few seconds. Here you can see equation 1000 times B8 divided by 10. B8 is the G star times 1 over sine radians C8 to the power of this. Okay. I'll just copy and paste the same. Well, I didn't need to do this until here. Okay, these numbers, did you get these numbers?
Yes.
Yes, okay. Now let's just take the log of this and the log of this. You just copy paste to the right, and the logarithm of the temperature. And save our work. You can see automatically this graph should show up, so you can see log n to the temperature. So then, you know, you have the best fit line. When you draw the best fit line, you would see A is 2.4 and VTS is 7.4823. Okay. Okay, so let's move on. Now we got the A-VTS relationship established. Now we have A is equal to what? 2 point minus 2 point. By the way, you probably know this, but if you do this, equals intercept. This is, will give you this intercept of this line. If you choose these y values, which is log n, comma, log of temperature as your x values, so intercept and enter, you will see it will give you 7.48. That's your A. Okay? And for VTS, you say equals slope of, these are the y, comma, these are the x, and that's your VTS number. So you have 7.48, 2 point, minus 2.405.
Go back up to VTS. What's your answer?
Just the slope, slope. So that's slope and intercept. These are neat commands in Excel. So you don't have to do a trend line on a graph every single time. So we have A and VTS relationship established. Now, so we have this. Now let's go to the next step. What is the next step? So next step is to develop this Excel sheet right here. This is what we will try to develop, and we will try to fit this. So first thing, what we will do is we will be calculating all these temperatures from this temperature, and then the time from the frequency, essentially 1 over frequency is time, and then we will use A-VTS relationship to calculate logarithm of the viscosity. Why are we doing this? Because if you go back a few slides, if you remember, so logarithm of viscosity minus logarithm of viscosity at reference temperature, we need that to calculate the shift factor. So let's go and do that in our Excel sheet.